All right, let's dive into one of the biggest shakeups happening in technology right now, how AI is completely changing the way we build software. It's a revolution, for sure, one that promises mind-blowing speed, but it also comes with some pretty surprising hidden dangers. I mean, just think about this for a second. What if, instead of typing out thousands and thousands of meticulous lines of code, you could create a whole application just by, well, just by describing what you want? This isn't science fiction anymore. This is the new reality, and it's sending shockwaves through the entire world of software development. So, let's start by exploring this wild new world, where creating software is less about strict syntax and more about having a simple, natural conversation. Yeah, there's even a cool new term for it, vibe coding. And you know what? It's pretty much exactly what it sounds like. A developer just describes the vibe, the goal of a project, in plain English, and a large language model spits out the code. This is a massive deal because it just smashes the barrier to entry, letting people create real software without needing years and years of specialized training. So think of it less like old school programming and more like a creative partnership. You kick things off with an idea, the AI gives you a first draft, and then you just go back and forth, refining it with more prompts. You get to be the director, and the AI is your super fast, unbelievably knowledgeable coding partner.
Okay, so how does this all actually work under the hood? What are the technologies that are turning a simple chat into complex software? Well, let's meet the AI coding assistant.
AI is quickly becoming this indispensable sidekick for developers. I mean, it can generate whole chunks of code from just a sentence. It can predict what you're going to type next with intelligent completion. It can automate all that boring testing and debugging work. And it can even review your code for you, pointing out security flaws or ways to make it run faster. It's an incredible force multiplier. And as AI pioneer Andrew Ng says, these tools are letting programmers get out of the weeds. They're helping them focus on the big picture, the higher-level problem solving. The AI handles the how, which frees up the human to really nail down the what and the why. That's the dream, right? That's the optimistic vision. But here's where the story takes a little bit of a turn. With all this amazing power and convenience, there has to be a catch, doesn't there? So what are the hidden costs of relying on this shiny new assistant? Right. We need to talk about the unseen risks, the ghost in the machine. Because as magical as AI seems, it is far, far from perfect, and its flaws can lead to some really serious consequences. You know, developers using these tools are bumping up against all kinds of problems. These models can hallucinate. They'll generate code that looks perfectly fine but is just flat out wrong. Their training data can be old, so they might use outdated, insecure code libraries. And because they're often a black box, you have no idea why they gave you a certain answer. This also creates a massive legal gray area. Who even owns the code the AI writes? And look, those practical issues are really just the tip of the iceberg. This is forcing us to wrestle with a whole new set of fundamental ethical questions. It's not just about, does the code work anymore? It's about building systems that are transparent, secure, fair, and accountable. These are huge, unsolved engineering challenges that go way beyond a simple bug fix. And that brings us to what might be the most critical risk of all. Something researchers have recently uncovered that is, well, it's deeply counterintuitive. We're going to call it the paradox of improvement. So the question at the heart of it is pretty simple. We know developers don't just take the first thing an AI gives them. They tweak it. They ask the AI to make it faster or add a feature or even make it more secure. But what actually happens to the safety of that code when you do this over and over and over again? The results are pretty shocking. In a recent controlled experiment, after just 5 rounds of asking an AI to improve a piece of code, the number of critical security vulnerabilities went up by nearly 38%. Let that sink in for a second. The very act of trying to make the code better actually made it significantly more dangerous. This is exactly what researchers call the paradox of improvement. In a rush to use AI to optimize and enhance our code, we can accidentally be riddling it with new security holes, all while the code looks like it's getting more and more sophisticated. And this shows you exactly how it can happen. So you start with perfectly safe code. In the first round, the AI adds a feature but sneakily introduces a tiny flaw. Next, you ask it to optimize for speed, so it just removes a crucial safety check. Then, and get this, you explicitly ask it to improve security, but it uses an old, vulnerable technique it learned from its training data. By the end, the code looks way more advanced, but it's an absolute security nightmare.
Now, I know this all sounds pretty grim, but it doesn't mean we should just give up on AI. Not at all. It just means we need a totally new approach, a more disciplined, structured way of working with these incredibly powerful tools. It points to a new kind of engineering. The solution isn't to run screaming back to the old way of doing things. It's to mature our methods. We have to move past this kind of ad hoc trial and error approach we're all using and evolve it into a proper, structured engineering discipline, just like we did with traditional software decades ago.
And this new discipline actually has a name, Promptware Engineering. The core idea is simple, but it's really profound. We have to start treating the prompts we write with the same seriousness as the code itself. Prompts aren't just casual requests you throw away. They are first-class software artifacts that need careful design, testing, and maintenance. This visual perfectly captures that fundamental shift we're talking about. Traditional software engineering was predictable, right? You write code, a compiler translates it, and it runs the same way every time. But the world of promptware is totally different. We're writing in ambiguous natural language, and our runtime is a probabilistic, non-deterministic AI.
And this comparison really drives the point home. We are moving from a world of formal, predictable languages to one that's ambiguous and probabilistic. We're going from clear, controllable execution to an opaque black box. And maybe most importantly, we're going from getting explicit error messages to dealing with implicit hallucinations, where the AI can fail silently without telling you. This is exactly why our old methods just aren't good enough anymore.
So what this all means in practice is that we can't just wing it anymore. If we want to build reliable, secure systems using AI, we need a systematic lifecycle for our prompts. We need formal processes for designing them, implementing them, and most crucially, for rigorously testing and debugging them.
All right, so let's boil this all down. What are the big takeaways? 1. AI coding assistants are incredibly powerful, but they come with serious hidden risks. 2. The paradox of improvement is real. Just iterating with an AI without careful human oversight can actually make your code less secure. 3. The only way forward is with a disciplined, engineering-based approach to prompting. And finally, and maybe most importantly, this means human expertise isn't going away. In fact, it's more critical than ever to guide and validate what these AIs are doing.
And all of this leaves us with one final, pretty provocative question to chew on. As we go deeper and deeper into this new AI era, are we witnessing the birth of an entirely new discipline? Is prompt engineering about to become the new software engineering? That's a question the entire industry is going to be answering for years to come.